Blue Gold, 9 Sustainable Development Goals, 9 episodes to discover inspirational stories about water. Episode 7, Paying our debt to the oceans and lakes.
The old phrase in the 1950s was the solution to pollution is dilution. So you just chuck it in the sea and then it just dilutes out and you don't see it anymore. And what we can see is that isn't the case. My name is Dr. Warren Cairns and I work on the analysis of trace elements and particularly mercury in the polar ice caps in polar regions.
The Randle Reef site has been described as a spill in slow motion. The site is contaminated with PAH known as polycyclic aromatic hydrocarbons, which are present in very high concentrations and are of greatest concern because they're known to be persistent, toxic, and carcinogenic. My name is Roger Santiago. I'm head of the Sediment Remediation Unit for Environment and Climate Change Canada. I'm working on the Randle Reef Sediment Remediation Project in Hamilton Harbour.
Up to 20 million tons of plastic goes into the ocean every year. That's as much as 3 kilograms per person each year. Plastics make up roughly half of each person's contribution to ocean pollution. Fertilizers, manure, and untreated sewage pollute the ocean at a rate of 1.4 kilograms per person per year. This causes hypoxia or dead zones in the ocean, killing off marine wildlife. Waste oil from vehicles and machines enters the ocean at a rate of 180 grams per person every year. And other pollutants, like mercury, are introduced to the ocean in small but devastating amounts.
These figures from the United Nations in 2017 are appalling. To turn the tide, the question we must urgently answer is, as the UN states it, how do we move from the ocean we have to the ocean we want? The SDG 14 is about life below water and aims to conserve and sustainably use our seas and lakes and the resources in them. While we may hope our abuses can just be swept into the water, unseen and forgotten, our oceans and lakes remember. In this episode, from Lake Ontario to the Antarctic, we will see how Veolia Water Technologies is helping to remediate pollution and understand how our behavior today is impacting the seas and the planet of tomorrow. Let's first go to Hamilton Harbour on Lake Ontario and find out more about Randle Reef, Canada's largest sediment remediation project in the Great Lakes, begun in 2016. Let's hear from Roger Santiago, who leads the project. Mr. Santiago works at the ECCC, or Environment and Climate Change Canada, responsible for coordinating Canada's environmental policies and programs.
Hamilton Harbour was first identified as an area of concern in 1987 under the Great Lakes Water Quality Agreement between Canada and the United States. Contamination at the Randle Reef site dates back to the late 1800s. The contributions of these sources of contamination have included coal gasification, petroleum refining, steel production, municipal waste, and overland drainage. Randle Reef contaminated sediment has contributed to restrictions on fish and wildlife consumption, fish and wildlife deformities, and also reproductive problems within Hamilton Harbour.
At Randle Reef, this heavily polluted area in the harbour is roughly the size of 75 football fields.
The goal of the Randle Reef project is to isolate this contaminant source and to stop its spread throughout Hamilton Harbour by using an engineered containment facility, or ECF.
Dave Lawrence, Senior Project Manager at Public Services and Procurement Canada and a main partner in the Randle Reef project, explains in more detail how the project confronted the nearly 700,000 cubic meters of contaminated sediment.
We constructed an engineer containment facility, or ECF, which is essentially a large island about 3 kilometers in circumference By building this island out in the harbor, we contained approximately 140,000 cubic meters of the contaminated sediment without even touching it. We've encapsulated that.
Then, the rest of the most contaminated sediment was hydraulically dredged and placed inside the ECF. This is where Veolia Water Technologies played its part, cleaning the vast amounts of water disproduced so that it could be safely returned to the harbour. But the most innovative part of this project is how the ECF won't just protect the harbour from the pollution, but will become a resource for future use.
We're building it so that a cap can be placed on top that can be finished with asphalt paving so that the Port Authority can take over the site and continue to use it into the future as a wharf, and also maintain the monitoring of the contaminated sediments during that time period.
The Randle Reef project combines existing approaches, but in an innovative way. Working with local partners, it has sought to be effective but also sustainable, and with time, to return Hamilton Harbour to the conditions it once enjoyed. If Canada is facing up to its industrial legacy on Lake Ontario, let's now travel to the Antarctic, where cutting-edge science is being used to rediscover our past on an even greater scale. Here, the impact is not on a harbour or even on a Great Lake, but our entire ecosystem. To get there, we need to make a stop in Venice, Italy. It might seem surprising, but what happens at the poles affects everyone. It affects some even more than others, such as the city of Venice. Let's let Warren Cairns explain.
I'm a researcher with the Italian National Research Council in the Institute for Polar Sciences. I live and work in Venice, which is a city on the front line of climate change. We're only at certain times of day a few centimeters above sea level.
Famously, Venice itself is subsiding, but a third of the change is due to the rise in sea levels.
It's something that's just very, very evident here. You walk around Venice and you see steps to go down, to go into the family gondola outside the palazzi, and they're underwater. They're never above water now, these steps that were installed in the past.
In 2005, Italy and France jointly established Concordia, a permanent year-round base in the Antarctic. This is one place where Dr. Cairns and his colleagues have taken ice cores.
And the specific point of Concordia station is the ice at that point is over 3,000 meters thick, and we hope to find ice from over 1.5 million years ago, and we work to look at understanding and separating the natural signal from the man-made signal so we can help our colleagues in other institutions improve their climate models and environmental models.
Ice cores are often taken within the top 3 or 4 meters of ice, but can also be taken from several kilometers down.
Depending on where you are in Antarctica, that then means how far back in time you go, because in Antarctica the snow accumulates in layers, a bit like tree rings, and so each year the pollutants, the air and anything else in the air is trapped in the ice or in the bubbles between the snowflakes.
Working at this level of precision requires that the equipment be extremely clean. This is where Veolia Water Technologies contributes its expertise.
Because we're looking at contaminants in Antarctica, which is effectively a large open-air clean room, we have to clean everything before we go, which means using large amounts of ultra-pure water for washing, rinsing, cleaning and decontaminating all the materials we send down to Antarctica.
The data from this research has informed everything in climate science, enabling scientists to understand the past and plan for the future. Speaking of planning ahead, a new research project began in December 2021.
We've got a project called Ice Memory, where we're actually collecting ice core samples from different parts of the world, and we're going to store those ice core samples in Antarctica in the hope that they'll be saved before the ice cap where they come from has melted. And so instrumentation that will have improved in the future can then get a lot more information from these ice cores than we are able to get at the moment.
We are racing against the clock. As the Randle Reef project demonstrates, concrete and sustainable solutions can be found to mitigate the damage already done.
There's been a lot of progress within industry and within the public recognizing our impacts of our operations and our actions on the Great Lakes and water quality. And we've seen a real change and a reduction of the sources of pollution over the last few years, and an incentive to fund the remediation of those existing legacy sites so that we can start to improve our water quality into the future.
I'm quite optimistic that we're on the right path, focusing on resiliency, sustainability, and the beneficial use to ensure that future contaminated sites are appropriately managed.
But make no mistake, though it may be hidden beneath the waves or in the ice, it's still our responsibility.
So in the end, what goes around comes around. We have to look after our planet. We have to, instead of throwing pollution in that then gets taken somewhere else, we have to deal with it. So future generations don't have to. It's our fault. Since I was born, over half the carbon dioxide that's in the atmosphere now has been generated. So it is my generation, my parents' generation, who did most of the damage. So we have to take responsibility, because otherwise we're going to leave a very bad legacy for our children.
The clock is ticking. Less than 10 years is left to meet the targets we have set ourselves. A decade for action, as the Secretary General of the United Nations, Antonio Guterres, calls it. So let's act today. We are all resources.